Okay, today we're dealing with linear inequalities, although there will also be some absolute value inequalities, and I think a couple of quadratic inequalities, but I'm not positive off the top of my head. Linear inequality is an inequality in two variables. Instead of a straight line, it's an inequality that is not just a straight line. It also has a range of values. It's got an inequality instead of an equal in it. You will be shading one side or the other. My suggestion is highlighters work really good for stuff like this today. Boundary is the line. We're going to have to graph the line and shade one of the two sides. Half plane, that's the solution. One half plane contains all the solutions, the other one does not. We're going to shade the side that has all the solutions. Test point. How do you know which side of the line to shade? You pick a point and you test it. That's what you have to do. The test point is you have to do that. You pick a point that's not on the line. You plug it into the equation and see if it's true or not. If it's true, the side of the line that contains the point you tested gets shaded. If it comes up false, the other side of the line gets shaded. It's as easy as that. You have to remember, when you're dealing with an equation, you get x equals 5. That's a single numerical solution to x. If you have an inequality, x is greater than 5, that is a range of solutions. That's a range of answers. Every number greater than 5. If you have a line, 2x plus 3y equals 5, and you get a line for it, that line is all the xy coordinates that make that equation true. If you have an inequality, you have all the points on that line plus one complete side or the other. It's a range of an infinite number of solutions. The only way to demonstrate all the possible solutions is by graphing, having a picture of the graph, all the coordinates that work. That's what we're doing. We're giving a two-dimensional solution to an inequality. You're showing me all the possible answers that will work. The infinite number of answers that will work, because that's what you technically have. When you have an inequality, you have an infinite number of solutions. You cannot list an infinite number of answers, but you can draw them and graph them, and the picture can demonstrate them for you. That's what today is about, showing me an infinite number of solutions. Okay, so really pretty easy. There's a couple of things you need to remember. Is that you're going to have a dashed line or a solid line. Let's actually go back to here. And if I extend down here, if I have a less than or a greater than only, I have a dashed line because the points on the line are not actually part of my solution. If I have a less than equal to, a greater than or equal to, my line that I graph is a solid line, because the numbers are actually part of it because it's or equal to. This is important in your graphing. When I check your graphing on the tests and quizzes, I'm going to look, is it dashed or solid, as it should be. So if we look at our first example, this one should be a dashed line, okay, because it doesn't have the or equal. And I graph it. It's an mx plus b form. I'm graphing an mx plus b form. My y-intercept is 0 because I have plus 0 here, right? Goes through the origin. My slope is -4, and that's -4/1. So I go down 4 and over 1. And I'm going to pause. Okay, let's see if this works a little better. Oh, yes, much better. Right actually where I want it to go. So I started the origin, go down 4 over 1, and I have a dashed line through there, and I know it's not perfectly straight. Get over it. Okay. Now, I have to pick a point that's not on the line. I have to test a point in the equation. Normally, the point I choose is the origin because it's the easiest. 0 for x, 0 for y. Makes it really easy. However, this line passes through the origin. I cannot use the origin in this particular case. I have to pick another point. So I'm going to pick something else that's really easy that I know the line does not go through. the line does not go through the point 1, 1. Doesn't pass through 1, 1. So I take that point and I plug it in here, put in 1 for y, put in 1 for x. Is that a true statement? Is 1 less than -4? No, it is a false statement, which means this is not in my solution set. I shade the other side of the line. The point I tested is not a solution. It doesn't work, so it's not in the shaded area. That means the other side is shaded. Okay. Now, I have to do the same thing here. Is this one going to be a dashed line or a solid line? Solid line, because it's or equal to. Solid. Okay. Now, this is not in mx plus b form. It's in standard form. X, y intercepts. Let x be 0. I get 2y equals 8. Divide both sides by -2. Y equals -4. That's my y-intercept. Let y equal 0. -3x equals 8. X equals -8 thirds. X equals -8 thirds. And you're thinking, how do I graph -8 thirds? Bless you. Well, -8 thirds is 2 and 2/3. So I go approximately 2 and 2/3 in the negative direction on the x. Am I exactly 2 and 2/3? No. But I am close enough for anything that we are doing in here. I don't need to be exact. My dad would say, close enough for government work. Okay. Draw a line through those, and this one is a solid line. Okay, you with me so far? I hope. Pick a point. What's the easiest point to test? 0, 0, the origin. That's my test point. Plug in 0 for x, 0 for y. Is 0 minus 0 less than 8? Is that true? Yeah, it's true. Which means that this is in my shaded area. That's what you need to do. Okay. You try it. Do those two. Okay, the first one isn't too bad. First thing I need to do, it is a solid line, not a dashed line. Find the x and y intercept. If x is 0, I get -3y equals 9. So y equals -3. That's my y-intercept. That's an easy one. Let y equal 0, I get 2x equals 9. So x equals 9 halves, or 4.5. 1, 2, 3, 4.5. And it is a solid line. Pick a point. The origin is the easiest point. 0 minus 0 greater than -9. Is that true? Is 0 bigger than 9? Nope. So this is not part of my solution. This is. Okay. So if I do x and y-intercept on the next one, it's a little goofier. It's a little bit of a problem. My y-intercept is 0 and my x-intercept is 0. That goes to the origin. I cannot graph it using x, y-intercept. I need to rearrange the equation for graphing purposes. So I subtract x from both sides and I get 5y. And for graphing purposes, I just go ahead and make it equal while I'm doing this. Equals -x. Divide by 5, and I get y equals -1/5 x. I know it goes to the origin. My slope is -1/5. My run is 5. 1, 2, 3, 4, 5. My rise is -1. Oops. It's supposed to be a dashed line, is it not? My bad. 1, 2, 3, 4, 5, down 1, and a dashed line. Okay. Pick a point. The origin obviously doesn't work because it goes through the origin. Once again, the second easiest number is 1, 1. If I know it doesn't go through 1, 1, I pick 1, 1. Is 1 plus 5 times 1 less than 0? No. Now, I have students who, oh, but Mr. Orris, it's less than. It's got to go below. Don't always count on that. Don't always count on that. Just because something is less than or greater than doesn't always mean, because this one, everything's greater than 9. I have students that, oh, I shade above because it's greater than. Doesn't always work that way. You have to pick a point and test it. You can't just rely on whether it's greater than or less than. You have to be careful about that. Okay, same idea, different problem though. I don't have x and y. I have x or y. These are still straight lines. When I have x equals some particular number, that is a straight vertical line. Probably the best spot is any right there. So yeah, x is greater than -2. This is a vertical line. X equals the vertical lines, y equals the horizontal lines. So this is a solid line because it's or equal to, and it goes through -2 on the x-axis. The shading on this one is actually easier. In this one, I can go bigger or smaller. I want all my x's to be what? Larger or smaller than -2? Larger. All my x's are larger than -2. Where are the numbers on the x-axis that are larger than -2? Over to the right. These ones are actually easier to shade as far as that goes, but you got to get the line going in the right direction. And a lot of students think, oh, x goes this way. Yeah, but the graph goes this way. Okay. Same thing on this one. Y is less than -4. Y equals our horizontal lines. This one's dashed line. So I find -4 on the Y. And I have a dashed line on that. And are my Y's smaller or larger than -4? I want all the ones that are smaller than -4. All the Y's that are smaller than -4 are all on the downside. Okay, does that make sense? Not too terribly difficult. I hope. Okay, do those two. Okay, so the first one, x is less than -1. It's a dashed line going through -1 on the x-axis, and I want everything less. Second one, y is greater than or equal to 3. Go through 3 on the y-axis, and it's a solid line, and I want everything bigger than 3. Questions so far? Okay, this is really great because this relates to what you were doing on Tuesday. So this is actually a test. Did you learn what you were supposed to learn on Tuesday? So I have to graph the inequality and run a test point through it. So I have absolute value, which means I'm going to have a V shape. Okay. Normally the vertex is at the origin. The -1 with the x -1 means I do what? I move it to the right one. Inside moves left and right in the opposite direction. This moves to the positive one on the x. The +3 on the outside means that I move the whole thing up 3. Inside parentheses, inside absolute values, inside square roots, inside almost everything is going to be the opposite of what the number is. Outside will be the same. Inside is almost always opposite. So X is inside, I move X in the positive one direction. Outside, I move up and down in the positive direction on this one. So I go over 1, up 3, that's my new vertex. And this is a dashed line, still a dashed line. Okay. So I do the exact same thing that I was doing. Move it over, move the vertex. This is what your goal was on Tuesday. What we're working on then. And because it's an inequality, I still have to shade. So I pick a point. Once again, the easiest point is the origin. 0 greater than the absolute value of 0 minus 1 plus 3. What is the absolute value of 0 minus 1? That's 1. Plus 3 is 4. Is 0 greater than 4? No. So this is not my shaded area. So I shade inside the V on this one. Because it came up false, so that point is not included. Okay. Same idea. The plus 2 means that I move to the left 2 places. Inside goes opposite. And then the minus 4 means that I go down 4. So I go over 2 and down 4. I go over 2 and down 4. 1, 2, 1, 2, 3, 4. This one's a solid line. And it's your standard V. And then I test. 0 less than or equal to 0 plus 2 minus 4. Absolute value of 0 plus 2 is 2. 2 minus 4 is negative 2. Is 0 less than negative 2? No. So the origin is not part of my solution. So I shade everything outside. If you're not sure, because of your graph, particularly on this or parabola one, of whether or not it passes through the origin, just pick a point you know for sure it does not go through. Any point will work that you know for sure it doesn't go through. Do those two. Okay. So the first one, it's a solid line, makes it easy for the graph. The minus 5 means that I move 5 in the positive direction, 5 to the right. The negative 2 on the outside means that I move down 2. So I go over 5, 1, 2, 3, 4, 5, and down 2. Here's my new vertex, and it's a pretty standard absolute value. Does not go through the origin. 0 less than or equal to 0 minus 5 minus 2. 0 minus 5 is negative 5, absolute value is 5. 5 minus 2 is 3. 0 is less than 3. So that means all of this is shaded. Okay. On this one here, the plus 1 means that I move to the left one. The plus 3 means that I move up 3. So I go over 1, up 3. Now the negative out in front means that I do what? I open down. It doesn't open up, it opens down. And this one's a dashed line. Now, once again, the origin does not go through. 0 greater than and negative 0 plus 1 plus 3. So this is negative 1 plus 3, that's 2. 0 is not bigger than 2. So I shade everywhere outside. Questions? Okay. I do believe that's it, right? Great.